File 13 of a Treatise of Human Nature by David Hume, Volume 1. This LibriVox recording is in the public domain. Read by George Yeager, Book 1, Part 2, Section 4, Objections Answered. Our system concerning space and time consists of two parts which are intimately connected together. The first depends on this chain of reasoning. The capacity of the mind is not infinite. Consequently, no idea of extension or duration consists of an infinite number of parts or inferior ideas, but of a finite number, and these simple and indivisible. It is therefore possible for space and time to exist conformable to this idea. And if it be possible, it is certain they actually do exist conformable to it, since their infinite divisibility is utterly impossible and contradictory. The other part of our system is a consequence of this. The parts into which the ideas of space and time resolve themselves become at last indivisible. And these indivisible parts, being nothing in themselves, are inconceivable when not filled with something real and existent. The ideas of space and time are therefore no separate or distinct ideas, but merely those of the manner or order in which objects exist. Or in other words, it is impossible to conceive either a vacuum and extension without matter, or a time when there was no succession or change in any real existence. The intimate connection betwixt these parts of our system is the reason why we shall examine together the objections which have been urged against both of them, beginning with those against the finite divisibility of extension. 1. The first of these objections, which I shall take notice of, is more proper to prove this connection and dependence of the one part upon the other, than to destroy either of them. It has often been maintained in the schools, that extension must be divisible in infinitum, because the system of mathematical points is absurd, and that system is absurd because a mathematical point is a non-entity, and consequently can never by its conjunction with others form a real existence. This would be perfectly decisive, were there no medium betwixt the infinite divisibility of matter and the non-entity of mathematical points. But there is evidently a medium. That is, the bestowing a color or solidity on these points, and the absurdity of both the extremes, is a demonstration of the truth and reality of this medium. The system of physical points, which is another medium, is too absurd to need a refutation. A real extension, such as a physical point is supposed to be, can never exist without parts different from each other, and wherever objects are different, they are distinguishable and separable by the imagination. 2. The second objection is derived from the necessity there would be of penetration, if extension consisted of mathematical points. A simple and indivisible atom that touches another must necessarily penetrate it, for it is impossible it can touch it by its external parts, from the very supposition of its perfect simplicity, which excludes all parts. It must therefore touch it intimately and in its whole essence, secundum se, tota et totaliter, which is the very definition of penetration. But penetration is impossible. Mathematical points are of consequence equally impossible. I answer this objection by substituting a juster idea of penetration. Suppose two bodies containing no void within their circumference to approach each other, and to unite in such a manner that the body which results from their union is no more extended than either of them. It is this we must mean when we talk of penetration. But it is evident this penetration is nothing but the annihilation of one of these bodies, and the preservation of the other, without our being able to distinguish particularly which is preserved and which annihilated. Before the approach we have the idea of two bodies. After it we have the idea only of one. It is impossible for the mind to preserve any notion of difference betwixt two bodies of the same nature existing in the same place at the same time. Taking, then, penetration in this sense for the annihilation of one body upon its approach to another, I ask any one if he sees a necessity that a colored or tangible point should be annihilated upon the approach of another colored or tangible point. On the contrary, does he not evidently perceive, that from the union of these points there results an object which is compounded and divisible, and may be distinguished into two parts, of which each preserves its existence distinct and separate, notwithstanding its contiguity to the other? Let him aid his fancy by conceiving these points to be of different colours, the better to prevent their coalition and confusion. A blue and a red point may surely lie contiguous without any penetration or annihilation, for if they cannot, what possibly can become of them? Whether shall the red or the blue be annihilated? Or if these colours unite into one, what new colour will they produce by their union? What chiefly gives rise to these objections, and at the same time renders it so difficult to give a satisfactory answer to them, is the natural infirmity and unsteadiness both of our imagination and senses when employed on such minute objects. Put a spot of ink upon paper, and retire to such a distance that the spot becomes altogether invisible. You will find that upon your return and nearer approach, the spot first becomes visible by short intervals, and afterwards becomes always visible, and afterwards acquires only a new force in its colouring without augmenting its bulk, and afterwards, when it has increased to such a degree as to be really extended, it is still difficult for the imagination to break it into its component parts, because of the uneasiness it finds in the conception of such a minute object as a single point. This infirmity affects most of our reasonings on the present subject, and makes it almost impossible to answer in an intelligible manner, and in proper expressions, many questions which may arise concerning it. 3. There have been many objections drawn from the mathematics against the indivisibility of the parts of extension, though at first sight that science seems rather favourable to the present doctrine, and if it be contrary in its demonstrations, it is perfectly conformable in its definitions. My present business, then, must be to defend the definitions and refute the demonstrations. A surface is defined to be length and breadth without depth. A line to be length without breadth or depth. A point to be what has neither length, breadth, nor depth. It is evident that all this is perfectly unintelligible upon any other supposition than that of the composition of extension by indivisible points or atoms. How else could anything exist without length, without breadth, or without depth? Two different answers, I find, have been made to this argument, neither of which is, in my opinion, satisfactory. The first is, that the objects of geometry those surfaces, lines, and points, whose proportions and positions it examines, are mere ideas in the mind, and not only never did, but never can exist in nature. They never did exist, for no one will pretend to draw a line or make a surface entirely conformable to the definition. They never can exist, for we may produce demonstrations from these very ideas to prove that they are impossible. But can anything be imagined more absurd and contradictory than this reasoning? Whatever can be conceived by a clear and distinct idea necessarily implies the possibility of existence, and he who pretends to prove the impossibility of its existence by any argument derived from the clear idea, in reality asserts that we have no clear idea of it, because we have a clear idea. It is in vain to search for a contradiction in anything that is distinctly conceived by the mind. Did it imply any contradiction, it is impossible it could ever be conceived. There is therefore no medium betwixt allowing at least the possibility of indivisible points and denying their idea, and it is on this latter principle that the second answer to the foregoing argument is founded. It has been pretended, lors de pensée, that though it be impossible to conceive a length without any breadth, yet by an abstraction without a separation we can consider the one without regarding the other, in the same manner as we may think of the length of the way betwixt two towns and overlook its breadth. The length is inseparable from the breadth, both in nature and in our minds, but this excludes not a partial consideration and a distinction of reason after the manner above explained. In refuting this answer, I shall not insist on the argument which I have already sufficiently explained, that if it be impossible for the mind to arrive at a minimum in its ideas, its capacity must be infinite in order to comprehend the infinite number of parts of which its idea of any extension would be composed. I shall here endeavour to find some new absurdities in this reasoning. A surface terminates a solid. A line terminates a surface. A point terminates a line. But I assert that if the ideas of a point, line, or surface were not indivisible, it is impossible we should ever conceive these terminations. For let these ideas be supposed infinitely divisible, and then let the fancy endeavour to fix itself on the idea of the last surface, line, or point. It immediately finds this idea to break into parts, and upon its seizing the last of these parts, it loses its hold by a new division, and so on in infinitum, without any possibility of its arriving at a concluding idea. The number of fractions bring it no nearer the last division than the first idea it formed. Every particle eludes the grasp by a new fraction, like quicksilver, when we endeavour to seize it. But as in fact there must be something which terminates the idea of every finite quantity, and as this terminating idea cannot itself consist of parts or inferior ideas, otherwise it would be the last of its parts, which finish the idea, and so on, this is a clear proof that the ideas of surfaces, lines, and points admit not of any division. Those of surfaces in depth, of lines in breadth and depth, and of points in any dimension.